Hello guys, welcome to this tutorial where we are going to introduce the divide and conquer in algorithm. Why is that so important as far as algorithms are concerned? Alright, so in the subsequent video that follows, okay, this tutorial, we are actually going to take some problems, okay, and solve them using the divide and conquer approach and the iterative method. Alright, and then we are going to explain each of them. So definitely don't miss those next tutorials so that you fully understand the concept of divide and conquer and how it actually works. Right, and before we jump into that, please make sure you have already subscribed to my channel. Thank you if you have already done that. Now let's move ahead and introduce what is divide and conquer. So in divide and conquer approach, the problem in hand is divided into smaller sub-problems. Alright, and then each problem is solved independently. When we keep on dividing the sub-problems into even smaller sub-problems, we may eventually reach a stage where no more division is possible. Okay, those sub-problems, that is, we can call them atomic, okay, smallest possible sub-problem are solved. So the solution now of all sub-problems is finally merged in order to obtain the solution of the original problem. So that's how the divide, okay, and conquer, the idea behind, okay, that term or that sentence. All right, as you can see there, we have problems, okay, a b c, okay, and until, as you can see there, as you can see, now we divide that problem as you can see there. All right, so the original problem is the whole of this, okay, that can be constituted of or make up of some, okay, elements, and then we break down that, okay, into sub problems and then obtain the solution, okay, the sub solution, and then we merge to have the final solution. Okay, so broadly we can understand divide and conquer approach in the three-step process, okay, as you can see there. So what is actually the divide or the break? Okay, some other people may call it break or so on, right? So now the divide, this step involves breaking the problem into smaller sub-problems. Sub-problems should represent a part of the original problem, right? So there should be a link. That sub-problem should not have shouldn't have something to do, okay, uh, should have something to do with the original problem. So this step generally takes a recursive approach to divide the problem until no sub-problem is further divisible. Alright, so at this stage sub-problems become atomic in nature but still represent some part of the actual problem. Alright, and the conquer, this step receives a lot of smaller sub problems, sorry, to be solved. So generally at this level the problem are considered solved on their own. Right, it may be too broad, okay, of us for now, but don't bother. In the next tutorial, upcoming tutorial, we're going to actually to explain what does that means, okay, and how it actually works, so with some examples, of course. So the merge or the combine, okay, so when the smaller sub problems are solved, this stage recursively combine them until they formulate a solution of the original problem. So this algorithmic approach works recursively and conquer and merge steps of, okay, works so close that they appear as one. Okay, so it's not that so explicit so that you can actually see. And some example of divide and conquer that we, okay, some example where we're going to actually to apply or to use the divide and conquer, you're going to see the merge search. Okay, the first we are going to talk about the iterative method and then the divide and conquer approach. All right, so we're going to see the merge sort, the quick sort, the binary search, okay, and so on. So please definitely don't miss that. Then see you in the next tutorial where we're going to actually, okay, try to have some good example to fully understand the concept of divide and conquer. Bye. Hello guys, welcome to this tutorial where we are going to introduce the divide and conquer in algorithm. Why is that so important as far as algorithms are concerned?